We are now going to present the Shoemaker Award. And for those of you unfamiliar, the Shoemaker Award is it's a Distinguished Scientist Medal. And in fact, I have the medal right here, that we present as a Lifetime Achievement Award given to a scientist who has significantly contributed to our understanding of the moon and other small bodies in the solar system. So this year, I am excited and proud to announce that Dr. Dan Britt is our recipient of the Shoemaker. So before I invite him up, I'm going to brag about him just a little bit. So first, he is a Pegasus Professor of Astronomy and Planetary Sciences at the Department of Physics at the University of Central Florida. He was educated at the University of Washington and Brown University and received his PhD there. He's served on the science teams of 4 different NASA missions: Mars Pathfinder, Deep Space One, New Horizons mission science team for the flyby of the Kuiper Belt asteroid 2014 MU69, and the Lucy mission science team for a series of flybys of asteroids near Jupiter. But wait, that's not it. He was the project manager for the camera on the Mars Pathfinder. And, you know, the biggest area of his contributions is in his research on the physical properties and mineralogy of asteroids, comets, the moon, and Mars. His research integrates natural sample science analysis with experimental petrology, orbital mission data, and geochemical modeling to explore the igneous evolution of the Earth, moon, and rocky worlds. A big part of the class work that he has done is creating the Exolith Lab, which is also in Orlando, Florida. It's a research facility for space hardware testing and regolith research managed by the Florida Space Institute. Is that right? Is it? Yeah, okay. As part of its operation, the lab characterizes and develops new recipes for lunar, Martian, and asteroid regolith simulants. In addition, they host the Lunabotic competition, which came out of the class team in partnership with Kennedy Space Center, something that we also support, and a really excellent robotic mining competition that we're expanding to other countries and international, just as a side. So Dr. Britt has served as the chair of the Division for Planetary Sciences of the American Astronomical Society and the Planetary Geology Division of the Geological Society of America. His honors include 6 NASA Achievement Awards, election as a Fellow of the Meteoritical Society, and asteroid 4395 Dan Britt named after him. So that's just the icing on the cake. No further ado, I'd like to invite you up to give you your medal. And Greg, do you want to come up for a picture? Get Greg up here. Oh, here's Jen. Okay. Oh, I need that. The floor is yours.
Wow. Thank you. I asked what I should say after this, and Christina said, well, why don't you talk about how you got into science? Probably it would be best if I just stopped here, but I'm going to tell you how I came to science because it was kind of an unusual journey. So next slide. Before I start, I just want to say a few words about Gene Shoemaker. Amazing guy. I never met him until 1991 when I was attending the Asteroids, Comets, and Meteors meeting in Flagstaff. And for their banquet and field trip, they were out at Meteor Crater for the banquet, and Gene Shoemaker led a field trip. And the note for the field trip was, wear sturdy shoes. And so what Gene did was took about 70 people, and we started walking around the rim. And we walked about a third of the way around the rim. And he said, well, all the interesting stuff is down in the crater. So we started climbing down the cliff, all 70 of us, which is why you had the sturdy shoes. And there were people in suits and street shoes. And some of the women had dresses and high heels. Mildred, the editor of Space Science Series, was in high heels. She climbed down also. People who had experience with rock climbing formed a human chain and passed people along. And all the while, Gene was pointing out the stratigraphy and the overturned flap. And I learned more that day about impact cratering than any days before or since. So an amazing guy. And right after that, we climbed back out. I pointed out to Gene there was a perfectly good trail that led back to the top. He said, oh, it's way more interesting up here. And up we went, climbing up. Reached the parking lot where the banquet was set out. And the sun was just setting in the west, and the full moon was rising in the east. And I thought, wow, this is a pretty good profession. I can get used to this. And it's been a lot like that for the entire career. I'd just gotten my PhD. How I came to this, next slide, was I basically had no interest in science growing up. I was not one of these people that stood out in the backyard and gazed at stars. I studied economics, got a bachelor's in economics, went in the Air Force, came out, got a master's, worked for Boeing, and was profoundly bored. And I started looking around for something that would be more interesting. And exploring the solar system seemed like it would be more interesting, not likely to be boring, and mostly has not been done. And what I did was I picked up Dave Morrison's book, The Voyage to Jupiter, and read it. Sounded pretty interesting. Flipped to the back of the book. Next slide. Because I needed to figure out what to study to get on a NASA imaging team, because I wanted to do missions. And in the back of the book, it listed all the people on these various teams, and I wanted to be on the imaging team. And so I looked at this, and I figured whatever these guys studied would probably work just fine, because it worked for them. Next slide. And so there are a couple of physicists, and I thought, well, physics is too hard. Next slide. There are a bunch of astronomers, but they were mostly physicists too, and I really wasn't very interested in telescopes. Next slide. Oh, mathematicians. Mert Davies. I've met Mert Davies, got to know him. I could never possibly do what he does. He is not just brilliant, but a wonderful human being. And that was way too much. But, I figured I'm not that interested in math. Atmospheric science, it combined the most difficult, mind-bending, complex parts of both physics and chemistry. So now, next slide. Geology. Rocks. I like rocks. I like being in the outdoors. I like mountains. I'll be a geologist. And that's how I decided on my PhD. Next slide. So I went back to the University of Washington. I was living in Seattle. Went to the graduate advisor, said, I want to get a PhD in geology and work on NASA missions. And he said, well, how much chemistry have you had? None. How much physics? None. How much geology? Oh, I had one course. And he gave me this long list of prerequisites and said, go take these and don't bother me, hoping I would go away. I went back, I got my BS in geology because all I needed to do was one more course over that list to get my full degree. And while I was there, I got lucky. I met John Adams. I started working for him. And John was really a leader in using spectroscopy to look at asteroids. He introduced me to the other people that were doing that sort of thing, this sort of remote sensing. And Carly Peters was crazy enough to take a retread economist at the age of 35 at Brown University. So I started there in 1985. When I walked in the door, I was the oldest graduate student at Brown University. I'll tell you a story. I ended up sitting next to the second oldest graduate student at Brown University, a guy from China by the name of Wei Dong. I said, 34, that's pretty old for a Chinese graduate student. And he said, well, yeah. I started undergraduate at the regular time, but then Cultural Revolution hit, closed down the universities, chaos for several years, and then they sent me into exile in Tibet for 9 years. I went, wow, that's a really good excuse. And then he smiled at me and said, what's your excuse? What could I say? If you remember the 70s, you never really lived them. Anyway, I wanted to do remote sensing of asteroids. And to do that, I needed to know about meteorites. And I got lucky some more. I applied for and won a summer fellowship to the Smithsonian, where they gave me a key to the National Meteorite Collection. That is me standing outside, smiling my ass off, because all of a sudden I had this kaleidoscope of stuff to study. I will tell you that there's no substitute for actually getting your eyeballs on these samples in order to understand the variety and the intricacies. And books in no way convey that complexity. And if anybody here is looking for something to work on, about 15% of all meteorites are actually unclassified. And it's just low-hanging fruit for somebody to start figuring out what the hell to do. Out of this work came several papers, just out of the blue, because I was looking at something and it didn't fit what people were telling me in books. Next slide. I got lucky some more. When I arrived at the Smithsonian, they usually put the summer graduate student fellows in broom closets and the equivalent. They were out of broom closets. The only available office belonged to the chair of the department. So that's the view I had out of my office for the summer I was in Washington, D.C. Yes, that's the Capitol in the background. Yes, that's the National Archives and the National Mall. So it was okay. And I thought, wow, I could do this. Next slide. And also I was Brown. And being at Brown at that time was amazing. There were amazing opportunities for travel and collaborations. The lower right-hand picture is my advisor, Carly Peters, in the hills of Armenia doing a field trip. The big picture is Jim Garvin and myself in front of some socialist realism art. Next slide. And then I postdoced at Arizona. And talk about getting lucky. I met and started collaborating with Guy Consolmagno, who said, well, I have this meteorite collection. I'm now the curator. Let's figure out something to do with it. And so we started doing density and porosity work. I will tell you, again, a note for all the young people in this room, is that one of the leading lights of asteroid science came up to me after we made our first talk. It says, you know, you're wasting your time doing meteorite physical properties. Nobody's interested. You won't find out anything. And he was dead wrong. We've published 28 papers on this subject so far. It's still an ongoing area of research. The other thing is that we did this research in some interesting places. That's the Pope Summer Palace in Castel Gandolfo. That's where the collection was held the first time we started working at it. My office is on the top floor in the corner. Right below my office was Pope John Paul II's sleeping quarters. And the problem you get when you're in Europe, of course, is if you call back to the States, you have to, you're 6 or 7 hours ahead. So I was in telecons with people at APL in the evenings. And I will have to admit that I ended up having a shouting match with an engineer at APL who had some strong opinions, and I had some strong opinions, and we expressed our strong opinions to each other. And John Paul II, who has since become a saint, sent a Swiss guard up to my office to tell me to shut up. But these opportunities are there. I got lucky. You can get lucky too. Next slide. So I was on 4 NASA missions. Next slide. This is what I wanted to do. On those missions, I ended up working with several of the people that were on that original list. So there's Toby Owen on Deep Space One. There's Larry Soderblom, who's on Pathfinder and Deep Space One. And to top it off, Dave Morrison, who was the chief scientist of SSERVI and one of the founders. I got to work with him being a SSERVI PI. So full circle. This is just great. There are so many people to thank. Next slide. I just want to thank everybody for letting me into an amazing field. It continues to be very interesting. It continues to be not boring. And really, it's still mostly not done. So there's a lot more to do. And I've had an opportunity to learn from the world's best. And I constantly think that I'm in a restricted area and I'm not authorized. But here I am. So thank you very much.